Hello everyone, today I'm going to be talking to you about integrating Okta with Kong, specifically using Okta's OIDc flows and using the Kong API gateway. So just to talk a little bit about Kong, it's an open source API gateway. You may have heard of others such as AWS, Amazon AWS, and MuleSoft, Apigee. In the case of Kong, it's open source, and this is kind of an overall architecture of Kong. So you have a client, unbeknownst to them, they may be going through this Kong API gateway, and it's built off of services such as rate limiting, logging, built-in authentication. It also has custom plugins that allow additional side effects, and the one that we're going to be focusing on in particular is the OIDc plugin, which allows us to interact with Okta. So why would you want an API gateway? This is kind of a more typical or an architecture that doesn't include an API gateway. And let's just say, for the sake of argument, you have three services that you want to expose. Maybe you have a load balancer or a gateway, and I have this allthethings.com here. So depending on where they're going, they may be directed through one of these three services. Without an API gateway, each of these services has to know how to deal with OIDc and either initiate the flow with Okta or be able to handle getting tokens from the user, from their browser, or from some other thing like their mobile app. So you can see here that for every connection as we pass through each of these services, they have to be aware of OIDc, OpenID Connect, and they also have to support the intended flow, and each of them interact with Okta directly. The benefit of having an API gateway like Kong in the middle is that it alone interacts with Okta for OIDc. It alone has to know how to deal with the OIDc flows, and then it just passes along a header that each of these services need to know how to deal with. So the services can be a lot thinner. They don't need a whole OIDc stack. All they need to do is to look for and to process this X-user info header in the case of Kong, and to set that up as a security assertion. And I'm going to show you how that works as we go forward. So the important things are, when you're using an API gateway, inside services should only accept connections from the API gateway, and inside services have to be able to deal with that custom header that's coming in and have it be the equivalent of a security assertion. So in the case of an OIDc interaction, we would expect a bearer token like an access token, and your app would not have to know how to deal with that. In this case, it's going to use this header coming from the API gateway as that security assertion. And since number one specifies that only the API gateway can connect, it's still a secure, well-managed connection because the authentication has already happened at the API gateway. And we'll see that it's also going to pass forward authorization information like group membership. So I want to talk a little bit about Docker in the context of this example. Docker makes it super easy to manage those constraints that I just talked about, to set up a scenario where your inside service will only accept connections from the gateway, and it's just an easy way to get this example that I created that I'll share with you in a little bit. It's very easy to get it set up locally or remotely or whatever you need to do. So this is kind of the Docker architecture. We have the Docker system. In my case, it's running locally on my Mac, and inside Docker, this is the, this cloud here represents Docker as a whole. There's a number of containers running inside Docker. So I have Kong running. Kong interacts with and stores information in a Cassandra database. And then I have Kong connecting to a Spring Boot application. And if you notice here, I've set up this internal Okta Kong Bridge network. It's another feature of Docker where you can set up your own networks. So I set up this internal Okta Kong Bridge network that these three containers communicate on, and I've set up some firewall rules. So the only outside connections that are allowed are 8000 and 8001. That's the user and admin ports on the Kong API gateway. I could have even further restricted it by not allowing outside connections to the 8001 port, but it's easier just for the purposes of demonstration, to let that through. But any direct outside connections that are attempted to be made to my Spring Boot application are blocked by the network firewall rules here. So this satisfies those requirements that I talked about a couple of slides ago. The only service here, the only container that can connect to my Spring Boot container is the Kong API gateway. So let's check all of this out in action. I have a project set up that I'll give you the reference to at the end here. It's called Okta Kong Origin Example, and it has everything that you need, the Docker definitions and the Spring Boot app, in order to get this whole thing set up. Now, I've already set up the Okta side of things, and what's required there is an application. So I have an OIDc application called Kong API Gateway, and on the README for this project, all of this is spelled out. So I'm going to go through it kind of quickly here, but you can see it in more detail on the README for this repo that I set up. So I created a couple of users, Joe user and Sally admin. I also created a couple of groups, admins and users, so because I want to demonstrate that even the roles information comes through on that assertion from Kong. Now, in order to do that, so what Kong sends through is the information that's contained in the ID token. So in order to make sure that all the group information comes through as well, on my authorization server, I set up some custom claims. The most important one here is groups, and I indicate that it should be on the ID token and that it should always be included. And that's going to help us to manage having the groups come through so that the Spring Boot application can then set that up in its security context. So the first thing we're going to do, so the way that Docker works is you have images and then you create containers off of those images. So we need to create a couple of images based off of this project. There's the Kong API Gateway image and there's the Spring Boot app image. And so first I'm going to go and create those images. The first one I'll create is the Okta Kong image. And I do that just by running this docker build command. Now this takes a little while, so through the magic of fast forwarding, we'll jump ahead. Okay, so now we've created the Kong image, and now we're going to create the Spring Boot example image. Once again, this will take a little while, so we're going to do the magic of fast forwarding. Okay, so now we've created our images and we can see what's there. So part of creating the Okta Kong image was to create this CentOS image. That's just the base OS that these are going to be running in. And then we have our Okta Kong OIDc image and our header origin example image. That's the Spring Boot app. Okay, so the next thing we're going to do is create our network that I showed you in that diagram previously. And you'll see in a moment that once we start creating containers from these images, we're going to specify that these containers have to use this network inside of Docker that we just created. Okay, now that we have our network created and our local images, we'll start to create the containers. And the first one we're going to create is the Cassandra database that Kong is going to use. And notice here it's using the network that we just created, the Okta Kong bridge. Okay, next we'll set up our Cassandra database for use. And so what this is going to do is set up the migrations for the database that Kong needs. And now we're going to create the Okta Kong OIDc container that's going to make use of that Cassandra database. Now, a couple things to look at here. We're passing in some environment variables, and notice one of them is this custom plugin OIDc. So the image was created having this plugin available, but we have to configure it for use. We're also passing in information like this trusted certificate location so that it can properly connect to Okta in a secure way using TLS. And finally, we're exposing a bunch of ports here to the outside world. So let's run that command. Okay. And now we're going to go ahead and create the container based on the image of our Spring Boot application. And notice here there's no -p parameters, so it's using the Okta Kong bridge internally, but it doesn't have any ports exposed to the outside world. Okay, so now if I take a look at my Docker containers, I have 3 Docker containers. I have the header origin example, that's the Spring Boot example. Then I have Okta Kong OIDc, that is the API gateway itself, and I have Cassandra, which the API gateway is making use of. And I can see that they're all created and they're all up. So this is a good checkpoint. These containers are all running and nothing crashed, and our whole system is now up and working. Okay, so the next thing we're going to do, now that we have Kong running, we kind of have a raw instance of Kong running. We want to configure it to use and connect to our Spring Boot application. So that's what this command is going to do. And notice the upstream URL here. We can call out header origin example. We can call that out by name because on our internal network that we created, it can resolve these different containers that we set up. So here I'm using HTTP, by the way. This is just a modern curl replacement. And I'm hitting Kong's 8001. That's its admin port so that I can configure it. So the first thing I'm telling it is that it's got an upstream URL to connect to. And the URIs that are going to be connected, that it's going to connect to, are just /. So any incoming connection to Kong is going to be forwarded on to this upstream URL. So it gives us a nice JSON response, 201 created, and it shows that that upstream URL rule has now been created. So the next thing we need to do now is to configure Kong to connect to Okta. And we've already set up Kong with the OIDc plugin, but now we need to configure that OIDc plugin to connect to Okta. And the only thing we need to provide it are a client ID, a client secret, and the well-known link for the OpenID configuration. And so I will get that right now. Okay, so this is going to set up the connection to this Okta tenant that I was showing you before, where I set up the users and the groups, and I have the OIDc application set up. And so now it gives us, once again, 201 created. So we created a rule inside of Okta, inside of Kong rather, to allow it to connect to Okta. And it's using the authorization code flow as we saw in the diagram before. Okay, so now that we've done all of that, we can actually see this in action. So I'm going to open up a new tab. So first of all, if I try to go to localhost 8080, can't reach it. There's nothing locally accessible there. But I can go to localhost 8000, and that is sending me to the Kong API gateway. Now once I'm there, notice I've been redirected to Okta. This is expected. This is a good sign that things are working. And the first thing I'm going to do is log in as Joe user. Okay, so it knows who I am now. And if I go to this users only endpoint, it allows me there, and it says the groups that I belong to are everyone in users. So that's good. Now if I try to go to admins, it says that I'm unauthorized. So this is good. So far everything's working as expected. Now let's once again go here, and this time I'm going to log in as Sally admin. And now this time I can go to users as before, and it shows me the groups that I belong to. Notice I also belong to admins in addition to the users group. So this time when I go to admins only, it lets me in. So the last thing I want to show you today is some of the internals of how this is working. So first of all, one of the nice things that we can do here with Docker is we can show the log that the Kong API is producing and see the ID token that it's verifying and using to pass along to our Spring Boot service. Okay, so let's take a look at the logs from Okta Kong OIDc. It's got a lot of output here. Let's scroll back a little bit and see if we can find some ID token information. So here's the ID token that was decoded from when we logged in as our user, Sally admin. So we can see her full name, and notice that the groups have been passed forward. So all of this information in ID token is being put into that X user info header. And if we were to scroll further up, we could also see the output from when our user, Joe user, logged in, and we would see that the groups there would just be everyone and users. So let's take a look at some of the code here. Now, this happens to be Java, but I think you'll see you don't need an extensive understanding of Java to kind of see what's going on here. The important thing is that this incoming X user info header is installed or set up as a security context in Spring Security in a way that then becomes idiomatic. So if you're a Java developer, hopefully this will look familiar to you. Here's where I'm defining my endpoints /users and /admins. And notice this pre-authorize has authority users. So this basically says only people that belong to the users group are allowed to hit this endpoint. Also, by the same point, only people that belong to the admins group are allowed to hit this admins endpoint. So this makes it kind of lean and easy to look at and easy to protect endpoints. And as you saw before, when I tried to go to the admins endpoint as my Joe user, it didn't let me in because this pre-authorize was not satisfied. Now, behind the scenes, what's going on here, if you're not familiar with Java, this may look complex, but you'll have to take my word for it that from the perspective of Java, this actually is not too complex. What's happening here is I have this function here that extracts the user from that X user info header if it exists and if it's able to. So here it's basically saying if that X user info header exists, then we're going to create a user object from that header. So that's the first step, is just ending up with a user object. Assuming that was successful, This is the piece here. It's really these 3 lines. Bear with me a second. There we go. It's these 3 lines right here that set it up or integrate it into Spring Security. Again, if you're not familiar with Java, this may look a little alien, but all we're saying is, first of all, clear any existing security context that may be there. That's just a precaution. Here's the important thing. We're creating this thing that's particular to Spring Security called a username password authentication token, and we're giving it that user object as well as the authorities. This is just, in simple speak, this is just the groups that the user belongs to. Once we've created that authentication, we're setting it inside the security context for Spring Security. So this filter is automatically executed, and if the xuser info header was set, then this security context is then set up, and from that point on, from the perspective of Spring Security, it functions in a normal or idiomatic way. And so that's what allows us to then use these simple constructs for determining if they're allowed to enter the method or not. So this part was very Java specific. You could do the same thing in almost any other language, Node.js Express or, .NET with C#. The important thing is that you're able to interrogate that xuser-info header. This is a much more lightweight operation. It's basically this one line that gives us the user object from our xuser-info header. This is a much lighter weight operation than having to have a whole OpenID Connect stack. That's already been taken care of at the Kong API gateway level. So I hope you found this informative. The repo is publicly accessible, and I'll make sure that the page where you find this this screencast has it, but you can also see it up here. It's just Okta Kong origin example, and it has everything that you need, including the detailed instructions for setting up your Okta tenant and for setting up Docker.